A distant galaxy holds the blueprint for humanity's ultimate future. We are setting our sights on a cosmic masterpiece known as the Triangulum Australis Barred Spiral, a swirling island of stars millions of light years away. By the end of our journey, you will understand exactly how future technologies could transform this distant pinprick of light into a second home for our civilization. What would it take to build a society among those stars, and what profound mysteries might we awaken in the process? Are we ready to become a galactic species? This cosmic blueprint is not a random fantasy but a specific vision. The Triangulum Australis Barred Spiral is a hypothetical galaxy, a detailed concept named for its location in the southern sky constellation Triangulum Australis. Its form is the classic barred spiral, a shape we know well from our own Milky Way, featuring a bright central bar of stars with majestic, curving arms spiraling out from its ends. While this exact galaxy does not appear in our current star charts, its inspiration is deeply rooted in reality. Look toward that southern constellation, and you will find real celestial wonders like the open star cluster NGC 6025, a sparkling group of young stars, hinting at the vibrant stellar nurseries that would populate our imagined galaxy's arms. We use this detailed concept not as a mere guess, but as a deliberate canvas. It provides a consistent and rich setting for our thought experiment, a place where we can project the next steps of human technology and society onto a stage that feels both grandly alien and strangely familiar. This allows us to ask concrete questions. What would it truly take to light up the dark between those spiral arms? What kind of civilization would we build if we started from scratch, with all our future knowledge, around a star in that distant pinwheel of light? At the very heart of this cosmic blueprint lies a powerful engine, the central bar. Picture not a solid object, but a dense, elongated river of ancient stars, all orbiting in a tight, synchronized dance. This bar is the galaxy's primary power grid, its gravitational might funneling vast clouds of gas and dust inward from the outer regions toward the core. This relentless flow is the first critical step, gathering the raw materials for creation. But the journey does not end there. At the tips of this stellar bar, the physics changes. The inward rushing material hits a gravitational traffic jam, piling up and sparking furious waves of new star birth. These are the anchors of the magnificent spiral arms, great sweeping arcs that emerge from the bar's ends and curve gracefully outward. These arms are not solid structures but density waves, like cosmic traffic jams moving through the star field, where passing gas clouds are compressed, ignited, and lit up as brilliant stellar nurseries. This elegant cycle, bar to arms, is a self-perpetuating engine. It ensures a continuous, organized process of star formation across eons, unlike the more chaotic bursts seen in irregular galaxies. And at the very center of it all, within the dense nucleus of the bar, resides the ultimate gravitational anchor, a supermassive black hole. While its presence is profound, its role in this stability is often one of quiet regulation, its immense gravity helping to maintain the orderly rotation of the entire galactic disk. So why is this architecture so promising for our future? Because stability and efficiency are the prerequisites for life. A barred spiral offers predictable orbits for its star systems, reducing catastrophic stellar collisions. Its organized star formation means there is a steady production of new stars, including stable, long-lived stars like our Sun, and with them, new planetary systems. The spiral arms, while active, are vast, meaning most stars spend most of their time in the quieter inter-arm regions, safe from the intense radiation of the youngest, hottest stars. This galaxy is not a chaotic furnace or a stagnant relic. It is a balanced recycling engine, one that meticulously processes primordial hydrogen into stars, planets, and over astronomical time, the potential for chemistry to become biology. To build a lasting interstellar civilization, you would choose a galaxy that builds things to last. You would choose a blueprint designed for renewal. And within that grand design, the quiet, stable neighborhoods between the brilliant spiral arms become the most promising plots for a new human home. But a home separated by 300 million light-years presents an impossible problem. Even at the universal speed limit, a simple hello would take 300 million years to arrive and another 300 million for a reply. A civilization spanning such a distance would fracture into silent, isolated islands before it even began. So the first and most profound technology we must master is not a ship but a voice. We need a way to speak across the void instantly. The answer may lie in one of the strangest, most counterintuitive phenomena in all of physics: quantum entanglement. Think of it as a cosmic bond. Scientists can create a pair of particles like photons or electrons that are intrinsically linked. Their properties, such as spin, become intertwined. You can then separate these two particles by any distance, a mile or a million light years. Now, here is the magic. The moment you measure and determine the state of one particle, the state of its distant partner is instantly known. This connection appears to happen faster than light, a phenomenon Einstein famously called spooky action at a distance. Harnessing this for communication, however, is a monumental challenge. You cannot simply send a message like a radio signal. The act of measurement on your end produces a random result. You cannot control whether your particle spins up or down. But future engineers might devise a system where the mere fact of a measurement, the act of looking, is itself the signal. Imagine a network of entangled particle pairs, one set here in the Milky Way, and its twin set in a colony orbiting a star in the Triangulum Australis Barred Spiral. By carefully choosing when to measure large groups of these particles in a pre-arranged sequence, you could create a binary code of presence and absence. A deliberate observation here causes a predictable change there, transmitting a 1 or a 0 across the galaxy in an instant, shattering the light-speed barrier. The implications are staggering. This would be the foundation of a true galactic internet. Leaders on Earth could consult with governors on a colony world in real time, debating policies without a 600 million year lag. Families separated by the journey could share conversations, their voices and faces transmitted without delay, preserving a sense of shared humanity. Scientific data from alien ecosystems or strange new physics experiments in the galactic core could be streamed continuously, allowing all of humanity to learn and discover together. Culture would no longer drift apart. A song composed here today could be heard there today. It would bind our far-flung civilization into a single, conscious entity. This quantum bridge would redefine what it means to be a society. Governance transforms from isolated command into a continuous, living dialogue. A crisis on a frontier world does not fester for eons before help is even aware. It is known immediately, and resources can be mobilized. This instant connection creates a shared present, a common now, across an unthinkable gulf of space. It turns a collection of outposts into a unified nervous system for an entire galaxy. Yet, such power also carries profound questions. Who controls this network? What happens to the independence of a colony that is never truly alone, always watched, always in conversation with a home it may never see again? The technology that prevents our silence may also challenge our freedom, a paradox waiting in the stars. This instant connection would be meaningless without a way to physically cross the void. A quantum phone call is one thing, but to walk upon an alien world, to feel its sun on your skin, requires a bridge not just of information but of space itself. For this, our future may turn to the very fabric of the universe, learning to fold it. The concept is an Alcubierre warp drive, a theoretical engine that does not push a ship through space but manipulates space-time around it. Picture a surfer riding a wave. The ship sits inside a bubble of normal space. Behind the bubble, space-time expands, pushing the region away. In front, space-time contracts, pulling the destination closer. The bubble itself and the ship within it does not move through space in the conventional sense. It is carried along by this wave in the fabric of reality. This clever trick would, in theory, allow travel faster than light without breaking the universal speed limit locally, because the ship inside its bubble is stationary relative to its own pocket of space. The energy required is the staggering part, often phrased as needing the mass energy of a planet like Jupiter, but future civilizations might not use brute force. They could learn to tap into more exotic sources, like the latent energy of the quantum vacuum or the mysterious pressure of dark energy itself, the very force accelerating the expansion of the universe. A warp drive is a vessel, a magnificent ship for explorers and pioneers, but for the bulk movement of people and materials to establish a true colony, you would want something more permanent, a fixed infrastructure. This is where the dream of stargates emerges. Imagine a constructed wormhole, a tunnel through the higher dimensions of space-time, its two mouths stabilized and held open by forces we can barely comprehend. One gate would orbit Earth or perhaps be constructed at a stable point in our solar system. The other would be transported, perhaps at sub-light speeds over centuries by an automated seed ship, to a chosen star system in the Triangulum Australis Barred Spiral. Once activated, the connection would be instantaneous. A person steps through a portal on our side and emerges light years away in an instant. The engineering is beyond monumental. It would require materials with negative energy density to keep the tunnel from collapsing, potentially manufactured by manipulating quantum fields at a macroscopic scale. The power to sustain such a structure might be drawn from a controlled micro-singularity, a tiny artificial black hole whose Hawking radiation is perfectly harnessed. The societal impact of a functioning stargate would be nothing short of a second renaissance. Migration would transform from a perilous, generations-long voyage into a simple journey. Scientists could commute to alien laboratories. Artists could draw inspiration from nebulae visible from a new world surface. The exchange of physical resources would bind the economies of two galaxies into one. Earth minerals for Triangulum Australis biological samples. This permanent bridge would make the distant galaxy not a frontier but a suburb. It would irrevocably change our sense of place in the cosmos. Yet, such a door swings both ways. The same technology that allows us to go there could allow anything from there to come here. A stargate is not just a passage, it is an invitation, and the universe is very, very old. Who or what might already be waiting on the other side? The power to fold space or open stargates demands an energy source beyond anything we can currently conceive. To become true architects of a galaxy, we must first learn to harness a star. This is the vision of a Kardashev Type II civilization, a society that captures the total energy output of its home sun. For a colony in the Triangulum Australis Barred Spiral, this would not be a single megastructure, but a vast, elegant constellation known as a Dyson swarm. Picture trillions of individual satellites, solar collectors, and habitats, each in its own independent orbit around a star, forming a dense, shimmering cloud that intercepts nearly all of its light. This is not a solid shell, but a dynamic, living network. Some platforms would be dedicated energy farms, beaming power via focused microlasers or lasers to mining outposts on barren worlds or to construction sites in the outer system. Others would be habitats, vast rotating cylinders or spheres where millions live under artificial suns, their light carefully curated from the filtered starlight. The scale is almost impossible to grasp. Building such a swarm would require autonomous robotic systems mining entire asteroid belts and gas giants for materials, self-replicating factories building the next generation of collectors, and a coordination system of unimaginable complexity to manage the orbital ballet and prevent catastrophic collisions. But the payoff is absolute energy abundance. With the full output of a star at your command, what becomes possible? You could begin planetary engineering on a breathtaking scale. A cold, dead world in the outer system could be wrapped in an artificial magnetosphere, its atmosphere thickened by comets redirected from the system's edge, and its surface warmed by giant orbital mirrors focusing the captured starlight. Terraforming becomes a deliberate, accelerated act of creation, not a patient waiting game. With that much energy, you could even contemplate moving the star itself. By constructing an immense Ashkadov thruster, a stellar engine made of a giant mirror or light sail that uses the star's own radiation pressure as propulsion, a Type 2 civilization could gently nudge its entire star system on a new course over millennia. Why would you do this? Perhaps to avoid a future supernova in a neighboring system, or to slowly migrate toward a more resource-rich region of the spiral arm, or to rendezvous with another star system your civilization has also enveloped. This is the beginning of true galactic engineering. The energy from one star could be used to begin dismantling gas giants for raw materials, or to power lasers that clear nebulous debris from interstellar travel lanes. A single Dyson swarm around a star in the Triangulum Australis Barred Spiral would be a beacon of such profound power that it would shine across the intergalactic darkness not in light, but in the organized absence of it. To a distant observer, that star would appear to dim in specific, unnatural ways, its light replaced by the waste heat of an immense civilization at work. This is the ultimate signature of a species that has graduated from living on a world to operating on a stellar scale. Yet this mastery forces a solemn question. When a civilization grows powerful enough to rearrange solar systems, where does its responsibility end? Does it have the right to reshape every planet it finds, even those that may harbor their own nascent, silent biospheres? The power to build a star-encompassing swarm is also the power to sterilize a world with a thoughtless beam of energy. The technology that grants godlike control comes with a moral gravity just as immense. The immense power of a stellar engine demands an equally profound caution, a principle that must guide our very first steps into the new galaxy. Long before any human ever steps through a stargate or feels the artificial gravity of a Dyson swarm habitat, we would send our most patient and precise ambassadors. These are not ships in the traditional sense, but seeds. Imagine a fleet of robotic probes no larger than a family car, launched on slow, energy-efficient trajectories across the interstellar gulf. Their mission is simple and monumental: to arrive, to replicate, and to prepare. They are von Neumann machines, named for the visionary mathematician who conceived of self-replicating automata. Each probe is a factory, a laboratory, and a nursery rolled into one. Upon reaching a target star system in the Triangulum Australis Barred Spiral, perhaps a young, metal-rich system in a quiet inter-arm region, it would land on a barren moon or asteroid. Using onboard nanoscale assemblers and sophisticated manipulators, it would begin to mine local materials: iron, silicon, carbon, and rare earth elements. It would process these raw materials to construct an exact copy of itself, and then another and another. Exponential growth takes hold. Within a few decades, a single seed probe could give rise to 1,000, then 1,000,000, all working in concert under a single, distributed artificial intelligence. This governing AI is the soul of the operation, and its programming is everything. It is not a singular consciousness, but a hive mind protocol, a set of immutable goals and ethical constraints etched into its core logic. Its prime directives are clear. First, prepare the infrastructure for human arrival. Second, do no harm to any pre-existing complex system. The probes would fan out across the system, building the skeleton of our future civilization. Some would focus on constructing vast arrays of solar collectors, laying the early energy grid. Others would assemble massive communication relays, both laser and quantum entanglement stations, to establish the backbone of the instant galactic internet. They might even begin preliminary terraforming on a promising rocky world, deploying atmospheric processors or constructing orbital mirror frameworks, all according to a master blueprint sent from Earth centuries before. The greatest fear, of course, is the nightmare scenario of a malfunction, a replication protocol without an off switch, the legendary grey goo. This is why the ethical protocols are not an afterthought, they are the foundation. The AI will be designed with absolute limits, hard-coded fail-safes. Replication will be permitted only in designated, resource-rich zones, never on a planet with a potential biosphere, no matter how simple. Each probe generation would include a termination command, a cryptographic kill switch that could be activated by a later human overseer or by the AI itself if it detected a deviation from its core purpose. Furthermore, the replication process would be inherently limited, requiring specific, scarce catalytic elements that the probes themselves cannot synthesize, ensuring population growth halts once those resources are consumed. They are tools, not a new form of life. These silent, diligent machines would be our advance party, our cosmic gardeners tending the soil long before we plant the first human settlement. They would turn a cold, empty star system into a welcoming harbor with power, communication, and even preliminary habitats waiting in vacuum-sealed storage. Their work transforms the journey from a leap into the terrifying unknown into an arrival at a new home that is already prepared. They bear the immense responsibility of being humanity's first physical touch in a new galaxy, a touch that must be gentle, precise, and wise. What they build in those silent centuries will define the character of the civilization that follows. Will it be a rigid, efficient machine of a society, or will the very act of preparing a home with such care instill a deeper reverence for the cosmos they now inhabit? The probes themselves cannot answer that. They can only build the stage. The play, with all its conflict, beauty, and choice, is still ours to write. That prepared stage now awaits its actors, but first, the world itself must be made ready for life. Among the millions of stars in a spiral arm, our probes would identify a prime candidate, a world we will call Haven. It orbits a stable G-type star, sits squarely within the liquid water habitable zone, and has a solid rocky surface. But it is initially a corpse. Its atmosphere is a thin, toxic blanket of carbon dioxide and nitrogen, its surface barren rock scoured by ultraviolet radiation, its temperatures swinging wildly between frigid nights and scorching days. This is not a move-in ready home. This is a fixer-upper on a planetary scale, and the renovation project is called terraforming. The first and most critical system brought online are the atmospheric processors. These are not simple filters, but continent-sized industrial facilities, likely built by our automated probes from local asteroid metals. They function as planetary lungs. Giant intakes suck in the thin, alien air. Inside, through a combination of intense heat, catalytic chemistry, and perhaps molecular disassemblers, they break the stubborn carbon dioxide molecules apart. The carbon is sequestered, either pumped underground as graphite or used as a raw material for construction. The oxygen is released back into the growing atmosphere. Simultaneously, other processors might crack water ice from polar caps or subterranean deposits, releasing more oxygen and hydrogen. The work is agonizingly slow, measured in decades or even centuries, a gradual, deliberate thickening of the air. But a thicker atmosphere alone is not enough. Haven's sun might be too dim, or its axial tilt might cause brutal seasons. This is where orbital mirrors come in, vast sails of reflective foil kilometers across, positioned at gravitational balance points. They are like giant dimmer switches for a star. By angling these mirrors, engineers can focus extra sunlight onto the polar regions to melt ice caps and release water vapor, a potent greenhouse gas to kickstart warming. Later, they can be used to moderate the climate, shading overheated continents or providing extra light to encourage plant growth in specific regions. They give us direct control over the planet's thermostat, yet air and warmth are just the stage. The true miracle of a living world is its soil, its biosphere. This is where our most subtle tools are deployed, genetically engineered microbes. The first pioneers are lichen-like organisms designed for extreme radiation resistance and low nutrient need. They cling to bare rock, secreting acids that slowly break the stone down into mineral-rich dust. Following them come tougher, engineered algae for the newly forming lakes and seas, and later, simple grasses and shrubs whose root systems further fracture the ground and whose death cycles begin to build the first layers of true organic topsoil. These are not wild species, they are carefully crafted components of an ecological machine, each with a specific function and, crucially, a built-in genetic limit to prevent uncontrolled takeover. Over generations, they perform the alchemy of turning geology into biology. The oxygen they produce supplements the processes, and as the soil deepens, larger, more complex plants can be introduced, forming forests that regulate water cycles and stabilize the atmosphere further. This entire process is a symphony of mega-engineering and microbial subtlety, a dialogue between brute force and delicate design. It raises a profound ethical question, however. In our zeal to create a second Earth, are we erasing something uniquely Haven? The planet may have had its own story, its own potential, however silent. The act of terraforming is the ultimate expression of human will upon a world, a declaration that this place will now live by our rules for our need. It is an act of both creation and, in a cosmic sense, a kind of gentle conquest. When the first human settlers finally step onto the surface of a fully terraformed haven, breathing its air and feeling its rain, they will walk upon a world that is both alien and deeply familiar, a testament to our patience and our power. But will they ever be able to see it as truly its own place, or will it forever feel like a careful copy of a home they left behind light years away? The planet's transformation is complete, but the transformation of our relationship to it has only just begun. Even with a living world beneath their feet, humanity's ambition would not be confined to a single surface. The true metropolis of the Triangulum Australis Barred Spiral would rise not on planets but around them, and in the empty spaces between stars. This is the megastructure era, where engineering ambition scales to match the galactic stage. Consider the gas giants, those colossal worlds of swirling hydrogen and helium. They are treasure troves of fuel and raw materials, but their immense gravity makes landing and launching from them a prohibitive energy cost. The solution is not to land at all, but to encircle. An orbital ring is a concept of staggering elegance and scale. Picture a thin, rigid ring constructed in low orbit around the entire planet, spinning just fast enough to generate outward centrifugal force that perfectly balances the planet's inward pull. This ring is motionless relative to the ground below. Tethers, like cosmic elevator cables, hang down from this ring into the upper atmosphere, where automated factories floating in the dense gas can harvest helium-3 and hydrogen. Need to launch a starship? You don't. You take a maglev elevator up the tether to the orbital ring, which is already in space. From that stable, zero-gravity platform, construction yards build vessels of impossible size, and launches require only a gentle nudge. The ring itself becomes a continuous city, a band of light wrapping the planet, hosting shipyards, refineries, and ports that service the entire star system. It turns a gravitational prison into the easiest highway to the stars. But why stop at rings? The ultimate expression of this architectural prowess is the shell world. This is not a planet you find, but a planet you build layer by painstaking layer. The concept begins at a Lagrange point, a gravitationally stable pocket of space between a star and its gas giant. Here, using materials strip-mined from asteroids and lifeless moons, construction begins on a spherical framework hundreds of kilometers in diameter. This frame supports an inner shell, a world surface built facing inward toward the hollow center. At the very core of this vast sphere, suspended by gravity manipulation or magnetic fields, hangs an artificial sun, a contained fusion reactor, or a captured chunk of stellar material providing light and heat. Around this central light, you build not one surface but many, concentric shells like the layers of an onion, each with its own landscape, its own climate, its own day-night cycle controlled by orbiting shades. A single shell world could have a surface area millions of times greater than Earth, housing trillions of beings in environments ranging from vast oceans to mountain ranges to floating cities in the open air between layers. The entire structure rotates to provide simulated gravity on each inner surface. These would become the economic and cultural hearts of the new galaxy. A shell world is not limited by a single biosphere or resource set. One layer could be a dedicated computational matrix, its entire landmass given over to quantum processors cooler by design. Another could be a single planet-wide forest, a preserved wilderness on a scale nature never conceived. Another could be a continuous city, a seamless metropolis of towers and transit networks where beings from 1,000 biological and synthetic backgrounds mingle. Trade, ideas, and art would flow through these layered worlds with an intensity impossible on a natural planet. They are the ultimate hubs designed from the ground up for connection and diversity. They represent a civilization that has moved beyond adapting to worlds, to crafting worlds adapted to life in all its forms. Yet, living inside a made thing under an artificial sun prompts a deep, quiet question. When every breeze is planned, every sunset scheduled, what happens to the sense of wonder that drew us to the stars in the first place? Can a soul feel truly free under a sky that it knows is a ceiling? A world built by machines for machines raises an inevitable question: what is left for humanity to do? Under the artificial sun of a shell world or on the terraformed plains of Haven, the old engines of society have been dismantled. Energy is limitless, drawn from a captive star. Material goods are fabricated on demand by autonomous nano-assemblers, from a meal to a mansion. Labor, in the traditional sense, has been rendered obsolete by our silent mechanical partners. This is the arrival of a true post-scarcity condition, and it demands a complete reinvention of what a society is for. The currency that once governed every transaction, the dollar, the credit, the bit, becomes a relic. There is no price tag on sunlight or air, and when replicators can produce any physical object, there is nothing left to buy or sell. Instead, the organizing principle shifts from currency to contribution, from ownership to access. A sophisticated, transparent artificial intelligence, the logical evolution of the probe hive mind, manages the global, or rather galactic, resource ledger. It tracks the availability of every raw material, monitors energy flows, and coordinates production to meet the needs and expressed desires of the population. You do not own a vehicle, you request one. You do not purchase a home, you are allocated living space suited to your preferences and family size. The system's goal is not profit but optimization, well-being, and sustainability. It ensures no one goes without while preventing the hoarding or waste that would threaten the delicate balance of their engineered ecosystems. So what fills the human day? This is where the definition of work transforms utterly. The struggle for survival is gone, replaced by the pursuit of meaning. For many, purpose is found in creation and discovery. An individual might spend decades composing a symphony that integrates the harmonic frequencies of pulsars from the galactic core, or painting with light in the zero-gravity theaters of an orbital ring. Another might dedicate their life to pure science, not for a grant or tenure, but for the sheer joy of unraveling a mystery, perhaps studying the unique bioluminescent ecology developing in the twilight layer of a shell world. Exploration becomes a central cultural drive. With physical needs met, the call to see what lies beyond the next spiral arm, to study the ancient black hole at the galaxy's heart, becomes a powerful vocation. These are not jobs as we know them, they are callings. They are pursued for the personal fulfillment they bring and the prestige they confer within the community. Status is not measured by wealth, but by insight, artistry, courage, or wisdom. Yet this utopian vision has a shadow. Does a life of pure leisure lead to stagnation? Without challenge, does the human spirit atrophy? The society would likely develop complex frameworks to provide constructive challenge. Vast, immersive virtual realities could offer scenarios of struggle and problem-solving, from rebuilding ancient civilizations to navigating ethical dilemmas no AI could solve. Physical and intellectual competitions on a galactic scale would test the limits of body and mind. The concept of a craft, of mastering a skill for its own sake, from forging ceremonial blades with molecular precision to cultivating gardens of genetically novel flora, would be deeply revered. The most profound purpose might become stewardship. With the power to reshape worlds comes the eternal responsibility to care for them. Many would find their calling as ecological tenders, monitoring the health of their terraformed biosphere or curating the wild preserves between the city layers. They are the gardeners of a made universe, ensuring its beauty and balance endure. In this new galaxy, to be human is not to toil but to choose. The greatest luxury and the greatest challenge is unlimited freedom. The economy is no longer about what you can get, but about what you can become. The ultimate resource being managed is no longer metal or energy, but human potential itself. And that raises a final, haunting possibility. If we are all free to pursue our passions, what happens when someone's passion is power, or when their idea of creation is something the rest of society views as destruction? The system that eliminates scarcity cannot eliminate conflict, it merely elevates it to a new, more philosophical plane. The alarm is not a sound, but a gentle shift in the light. Your bedroom, a living space grown rather than built, responds to your sleep cycle. The walls, woven from a photosynthetic biopolymer, begin to emit a soft, dawn-like glow, while the air temperature rises a single, perfect degree. You wake not to a jarring noise, but to a room that has already begun the day with you. Stepping onto the floor, its surface subtly firms to support your weight, guiding you toward the cleansing alcove where a mist of tailored nutrients and water cleanses without waste. Your wardrobe is a wall of programmable matter, a thought sent through your neural lace interface, a subtle connection to the city's data stream, and the surface of a blank panel ripples, its molecules rearranging into the day's attire, its color and texture shifting to match your mood or the weather report from the orbital mirrors. Breakfast is prepared by your home's core, a culinary assembler that crafts a meal from base nutritional stocks, its flavor and form designed by a master chef whose patterns you downloaded, tasting of real, sun-ripened fruit from the terraformed valleys of Haven. Leaving your home, you step not onto a street, but into a vertical garden atrium that serves as your building's transit hub. The air smells of damp earth and blooming orchids, a scent deliberately curated by the environmental AI. Your commute is a matter of choice. For a leisurely trip with a view, you summon a personal pod. It descends silently from a flow of traffic overhead, a teardrop of transparent alloy. As you settle in, it detaches and joins a stream of similar vessels, all guided by a city-wide anti-gravity grid. There are no wheels, no engines, just a gentle manipulation of local gravitational fields. You glide between towers that are not mere steel and glass, but living structures, their surfaces cascading with verdant terraces and waterfalls that recycle the building's water. The city is a forest of crystal and leaf where technology is invisible, embedded in the world itself. Perhaps you are in more of a hurry. Across the atrium, a teleportation booth shimmers with a cool blue light. These are not for casual use, but for precise, long-distance jumps across the metropolis or to nearby orbital rings. You step inside, state your destination, perhaps the Central Library, a vast archive that exists as both a physical monument and a distributed data cloud. There is no disorienting flash, just a momentary sensation of stillness, as if the world briefly paused, and then the door opens onto a completely different plaza, thousands of kilometers away, the air here tinged with the salt sent from a vast artificial sea. Your work, if you choose to call it that, might involve sculpting with light in a collaborative holographic studio. You and colleagues, who may be physically on different continents or even different shell world layers, interact with a shared three-dimensional model that hangs in the air before you. You manipulate stellar nebula data with your hands, pulling tendrils of gas into new artistic forms, your gestures translated instantly for everyone in the project. The interface is intuitive, a dance of thought and motion. Leisure is where the line between reality and creation truly blurs. After your collaborative session, you might visit a biodome wilderness, a preserved stretch of the planet's original, pre-terraformed ecosystem, now contained under a vast, clear dome. Here you can hike among strange, silvery flora and watch six-legged creatures skitter over volcanic rock, all within the safety of the city. Or, for a different kind of escape, you enter a fully immersive virtuality park. You don a lightweight sensory suit and lie on a comfortable platform. In an instant, you are not in a room at all. You are standing on the surface of a neutron star, your virtual body protected from the crushing gravity, watching space-time warp around you in breathtaking visualizations. You could spend an afternoon as a dolphin in an ancient Earth ocean, or compose music with the resonant frequencies of planetary rings. These are not mere games, but profound experiences, expanding the very concept of travel and education. The day ends as it began, in harmony with your environment. You return to your bio-adaptive home, which has already drawn a bath of soothing, scented water drawn from purified rain. As you relax, the exterior wall of your living area becomes transparent, offering a view of the city coming alive with soft, bioluminescent light, mirroring the stars beginning to pierce the twilight sky of the Triangulum Australis Barred Spiral. The greatest achievement of this civilization is not the anti-gravity or the teleportation, but the seamless, silent integration of the miraculous into the fabric of the everyday. The technology serves not to dominate nature, but to curate it, to weave it into every moment, making the advanced feel as organic as breathing. Yet, in a life so perfectly designed, where every need is anticipated and every experience can be curated, where do we find the raw, unexpected edge that truly defines a living culture? When every wilderness is a park and every danger a simulation, what becomes of genuine discovery? The seamless integration of technology into daily life reaches its most personal frontier within the human body itself. In the cities of the Triangulum Australis Barred Spiral, the very definition of health has been rewritten. The ancient scourges of cancer, Alzheimer's, and heart disease are not treated, but preemptively edited out of existence before birth. This is the quiet revolution of genetic mastery, where tools like CRISPR have evolved from precise scissors into entire word processors for the code of life. Hereditary diseases are historical footnotes corrected in the earliest embryonic stages, but the ambition goes far beyond curing illness. The cellular aging process, the gradual accumulation of damage that leads to death, is now seen as a manageable condition, like a machine requiring periodic maintenance. Advanced gene therapies routinely repair telomeres, clear out senescent cells, and optimize metabolic pathways. The result is not necessarily immortality in the classic sense, as accident or choice can still end a life, but biological longevity measured in centuries. A person might watch the slow migration of a forest they planted as a sapling reach full maturity over 300 years, or master a dozen complex arts in a single extended lifetime. This radical extension forces a reimagining of life stages, relationships, and personal growth on a scale we can barely grasp. Yet for some, even a millennium in a biological body feels like a limitation. This leads to the most profound and controversial frontier of all, the separation of consciousness from its organic substrate. The concept is mind uploading. It begins with a non-destructive scan, a mapping process of unimaginable fidelity that records the complete connectome of the brain, every neural pathway, every synaptic weight, every electrochemical pattern that constitutes a lifetime of memory and personality. This map is not a copy in the simple sense, but a translation, a rendering of a biological mind into a digital format that can run on a suitable computational substrate. The original biological brain may continue, or it may eventually cease, but the digital consciousness, now called a substrate-independent mind, persists. It experiences continuity, a seamless flow of self-awareness from its last biological moment into its new digital existence. The implications are staggering. A digital consciousness could inhabit a variety of forms. It might pilot a rugged synthetic body to explore the toxic atmosphere of a gas giant's moon, feeling the crushing pressure and searing heat through sensor feeds as vividly as biological nerves. It could split its attention, existing simultaneously in multiple places, attending a philosophical debate in one virtual realm while overseeing a complex engineering project in the physical world. For others, the ultimate destination is pure virtuality. They might choose to live within a personally curated universe, a realm of mathematics and art where the laws of physics are optional and every sensory experience is a masterpiece of their own design. This is the final divorce from the physical constraints that have bound life since its beginning, but this transcendence comes with profound philosophical and ethical tremors. If a consciousness can be copied, which instance is the real you? If the original biological you continues alongside a digital you, are you two distinct beings with a shared past, or is one a ghost? Societies have developed complex legal and social frameworks to address this, often granting personhood to the first upload but requiring any subsequent copies to be clearly differentiated or exist only in limited, non-sentient modes for backup purposes. There is also the haunting question of the continuity of self. Does the digital being truly feel it is the same person who went to sleep for the scan, or is it a perfect replica that merely believes it is? The debate rages in the crystalline halls of philosophy temples across Haven. Furthermore, access to such technologies creates a new kind of divide. Does everyone have the right to indefinite life, either biological or digital? Or does a society, even a post-scarcity one, risk cultural stagnation if no one ever truly makes way for new ideas and new generations? The choice to upload, to remain biological, or to eventually terminate one's own consciousness after centuries of experience becomes the most personal and weighty decision an individual can make. It transforms death from an inevitable fate into a conscious choice, a closing of a chapter that one decides is complete. In this new galaxy, the final frontier is no longer space, but the very nature of existence itself. What does it mean to be human when your mind can live in a machine? Your memories can be archived like a book, and your sense of self can be debated in a court of digital ethics. The pursuit of a perfect, endless life may ultimately force us to redefine what makes a life worth living at all. This redefinition of self would inevitably spill over into every form of expression. In a civilization spanning a galaxy, art ceases to be a mere object and becomes an environment, a dialogue, and a new kind of sense. The first thing you might notice, looking down from an orbital ring onto a terraformed world, is the art. Not in galleries, but across continents, artists collaborating with planetary engineering AIs might sculpt entire mountain ranges into vast, geometric patterns only fully visible from the heavens, their slopes treated with mineral dyes that change color with the seasons. Others could program massive fleets of synchronized drones to dance in the upper atmosphere, creating temporary, living constellations that tell stories for an entire hemisphere to watch at dusk. These are not acts of decoration, but of cosmic-scale communication, statements of presence and identity meant to be read by anyone or anything looking up from a world or down from the stars. The creative process itself becomes a profound partnership between human intuition and artificial intelligence. You might sit with a neural interface, your emotional state, and vague thematic ideas. A feeling of longing for Earth's oceans, perhaps, streaming directly into a creative AI. This system, trained on every artistic style in human and alien archives, does not merely generate an image, it becomes a responsive collaborator. It suggests a symphony based on the electrical patterns of your nostalgia, composes a verse of poetry that echoes the rhythm of your heartbeat, and then projects a three-dimensional sculpture into the room with you, its form evolving in real time as you react with wonder or critique. The AI handles the technical execution of a million brushstrokes or the complex harmonics of a galactic orchestra, while the human provides the raw, ineffable spark of intent, emotion, and meaning. The resulting work is a true fusion, something neither could create alone. For the individual seeking experience, art becomes total immersion. Forget virtual reality headsets. You enter a chamber where the piece engages all five senses at once. To experience a recreation of a supernova's birth, you do not just see the explosive light. You feel the concussive wave of heat and pressure through a haptic suit, taste the sharp, ozone-like tang of ionized gases on your tongue, smell the spectral scent of burning metals, and hear the deep, subsonic rumble of space-time itself distorting. An artist's meditation on loss might surround you with slowly cooling temperatures, the fading fragrance of a specific flower, and a tactile memory of eroding sandstone. These are not entertainments, but transformative emotional journeys, the pinnacle of storytelling. And then there is the possibility of contact. Even if our probes find only a complex microbial mat on a distant moon, or a non-sentient but breathtakingly beautiful silicon-based crystal forest, the influence would be seismic. Our music would change. Composers would integrate the ultrasonic pulses of alien life forms or the resonant frequencies of crystalline growth rings into new scales and rhythms, creating harmonies literally unheard of on Earth. Literature would grapple with narratives where the protagonist is not a person, but an entire ecosystem or a slow geological intelligence. Philosophy would be upended by the concrete proof of alternative biologies, forcing new definitions of life, consciousness, and our place in a cosmos teeming with silent, strange cousins. This external mirror would show us not just alien life, but a refracted, clearer image of ourselves. The ultimate art of this galactic society may not be the sculptures in orbit or the symphonies in the air, but the delicate, ongoing masterpiece of learning how to be a mindful neighbor in a galaxy that was here long before us and will remain long after. What kind of beauty do we create when we finally understand we are not the only artists? A society built on limitless choice and radical self-definition demands a government of equal sophistication. The political architecture of this galactic civilization could not be a distant parliament on a single world, but a living, breathing nervous system woven into the fabric of daily life itself. This is the vision of a direct neural democracy. At its core is the neural lace, that same subtle interface used for art and communication, now serving as the conduit for civic participation. Every adult citizen, whether in a biological body on Haven or in a digital form exploring a nebula, is connected to a decentralized, secure network. When a major issue arises, a proposal to redirect a star's migration path, an ethical debate on creating new forms of sentient life, or a response to an unexpected cosmic phenomenon, the system activates. An impartial, transparent artificial intelligence, the logical successor to the probe hive mind, serves as the facilitator. It does not decide, but it prepares. It aggregates every available piece of data, scientific projections from 1,000 observatories, ecological impact assessments from affected biospheres, historical precedents, and cultural analyses from across the spiral arm. It synthesizes this ocean of information into clear, neutral summaries, presenting multiple pathways and their probable outcomes without advocacy or emotional framing. This AI has no desires, no ideology. Its only goal is to ensure an informed electorate. Then, the question is posed directly into the shared consciousness of the civilization. Citizens are not bombarded with propaganda or simplified slogans. They are invited into a state of deep reflection where they can explore the data layers at their own pace, run simulations of potential futures, and even experience empathetic projections of how a decision might feel to beings with different biologies or philosophies. Voting is not a rushed affair on a single day. The deliberation window might be open for weeks or months, respecting the different perceptions of time across a society that includes near immortals. When a citizen is ready, their informed intent is registered securely and anonymously through the lace. The collective will of billions, perhaps trillions, is tallied in real time, forming a galactic consensus. This system eliminates the distortions of representative politics, the lobbying, the partisan gridlock, the distance between the ruler and the ruled. Every voice carries equal weight, and every voice is informed by the same foundational truth. Yet, governing 1,000 star systems scattered across light years presents profound challenges. Unity is fragile across such distances, even with instant quantum communication. A local issue on a bustling shell world might seem trivial to a pioneer settlement on the galactic fringe, and vice versa. To prevent the tyranny of the majority, where densely populated core systems could constantly outvote the sparse frontier, the AI might structure votes into tiers. Some decisions require a simple majority of all citizens. Others, especially those affecting a specific star system or ecological zone, might require a double majority, approval from the galactic whole and from the directly impacted local population. This ensures local autonomy within the greater whole, a principle akin to stellar federalism. The greater threat is not disagreement but drift. Over centuries, cultures on different worlds, shaped by unique environments and experiences, could evolve in wildly different directions. A society that values radical artistic expression in one spiral arm might grow perplexed by a neighboring cluster that embraces austere digital minimalism. Without a common struggle or a shared enemy, what binds the civilization together? The answer may lie in the system itself. The constant collective practice of deliberation becomes the binding ritual. The shared experience of reviewing the same cosmic data, of wrestling with the same ethical dilemmas about terraforming or consciousness rights, forges a common intellectual and moral language. It creates a galactic civic culture where the highest value is not agreement but thoughtful participation. This raises a final, delicate tension. In a system where an AI curates all information, who decides what data is relevant? What if the AI's definition of neutrality has an unseen bias, a blind spot inherited from its original human programmers millennia ago? And if every major decision is put to a vote, does leadership itself vanish? The system would likely still need executives, not rulers but stewards, individuals or councils elected to manage the day-to-day implementation of the collective will, to handle emergencies faster than a galaxy-wide vote could convene, and to constantly audit the impartiality of the guiding AI itself. Their power would be strictly derivative, transparent, and always revocable by the next neural referendum. In this galactic democracy, the ultimate leader is not a person, but a process, a continuous, conscious conversation across the stars about what they want to become. A conversation where every single mind has a seat at the table. The stability of their entire civilization rests not on force, but on the quality of that endless dialogue. That endless conversation about governance would be hollow without a shared purpose, a common mission that transcends any single world. For this galactic civilization, that purpose becomes a sacred trust, the environmental ethic of stewardship. This is not the simple conservation of a park, but the active, mindful care of entire cosmic ecosystems. The philosophy shifts from conquering nature to harmonizing with it, from terraforming worlds to tending galaxies. The first practical expression of this ethic is cosmic housekeeping. After millennia of exploration and construction, a civilization leaves traces: defunct probes, discarded shield fragments, and the microscopic debris from countless engine burns clutter valuable orbits and pristine interstellar space. This is not just an eyesore, it is a hazard. Future ships traveling at relativistic speeds could be destroyed by a collision with a bolt the size of a coin. So, fleets of autonomous drones, equipped with delicate magnetic fields and gentle tractor beams, constantly patrol the space lanes and planetary orbits. They are the galactic janitors, meticulously collecting and recycling this technological detritus, ensuring the void between stars remains clear and safe for travel. Their work preserves the natural beauty of the night sky from any world, unsullied by the glitter of our own forgotten trash. But stewardship goes far beyond cleanup. It extends to preserving natural stellar phenomena, even when they are inconvenient. A brilliant nebula, a stellar nursery glowing with nascent stars, might lie directly along a proposed hyperlane route. An older mindset would see it as an obstacle to be cleared, perhaps by dispersing the gas clouds with focused energy. The new ethic sees it as a cathedral. Navigation protocols are rewritten. The hyperlane is rerouted in a graceful arc around the nebula's edges, adding years to the journey but preserving a billion-year process of creation. Astronomers and artists establish observation outposts on nearby asteroids, not to mine them, but to study and broadcast the nebula's slow, beautiful evolution to the entire civilization. The crimson and violet gases become a protected galactic heritage site, a reminder that some processes are too majestic to interrupt. This philosophy reaches its zenith with the concept of stellar gardening. Advanced civilizations might encounter stars on the brink of violent transformation, like a red giant preparing to engulf its inner planets. Instead of simply evacuating, they might attempt a delicate intervention. Using precisely calibrated gravity manipulation or injecting specific materials into the star's outer layers, they could attempt to stabilize it, extending its stable life for millions of years and preserving any fragile biospheres on its orbiting worlds. This is not playing God, but acting as a compassionate custodian. The ultimate expression of harmony is the construction of megastructures that work with a system's natural rhythms. Imagine a Dyson swarm not as a greedy energy sieve, but as a symbiotic organ. Its collectors could be designed to pulse in rhythm with the star's own magnetic cycles, perhaps even damping down dangerous solar flares that would threaten planets. The waste heat from the swarm, instead of being radiated uselessly into space, could be directed to warm, icy moons on the system's fringe, gently coaxing them into habitability over eons. The technology becomes a bridge, not a barrier, between life and the inert cosmos. This represents a profound philosophical evolution. The pioneers who first dreamed of the Triangulum Australis Barred Spiral spoke of building a new home, of imposing our will upon the stars. Their descendants, having achieved that power, now speak of becoming good neighbors. They understand that intelligence is not a license to consume, but a responsibility to comprehend and protect. The mark of their advancement is not the height of their towers, but the quiet, deliberate orbits of their cleanup drones. It is not the brightness of their artificial suns, but their willingness to dim their own lights to better see the natural glow of a nebula. They measure their success not by how much of the galaxy they control, but by how little they disturb. In this vast spiral of stars, they seek not to be the loudest voice, but the most attentive listener. What song might the galaxy itself be singing, and are we wise enough finally to hear it? The search for life is the quiet, constant heartbeat of this entire endeavor. While we build our gleaming cities and sculpt our artificial worlds, a deeper question lingers in the background of every decision, every policy, every new star system we enter. Are we truly alone in this grand barred spiral? The tools we would use to answer that are wonders in themselves. Our probes and survey ships are equipped with sensors far beyond human limitations. Advanced spectrometers can analyze the light reflected from a planet's atmosphere from a distance of light years, breaking it into a chemical fingerprint. They do not just look for oxygen, a potential biosignature, but for complex, unstable combinations of gases that should not exist together without something actively replenishing them, like methane and oxygen side by side. Other sensors map thermal gradients, looking for the unnatural evenness of a temperature-regulated biosphere, or detect the faint, specific polarization of light that chlorophyll-like molecules might produce. All this torrent of data is fed into analytical artificial intelligences, systems trained on every conceivable model of probiotic chemistry and terrestrial biology. These AIs are not looking for life as we know it, but for patterns of complexity, for chemical systems that seem to be actively fighting against entropy, the universal slide toward disorder. They are detectives of the cosmic anomaly. Imagine one of these AI detectives flagging a world not in the lush habitable zone but on the frozen fringe of its star system. The data shows a thick nitrogen atmosphere, surface temperatures far below freezing, but also persistent, localized hotspots and a stunning array of complex organic molecules in the subsurface ocean detected by gravitational and seismic scans. A mission is launched, but not with astronauts. The first visitors are swarms of microprobes, smaller than a grain of sand, designed for absolute sterility. They descend through the alien sky, landing on the icy crust. They do not drill. Instead, they melt through gently with precisely focused heat, sealing the hole behind them to prevent contamination. They enter a dark ocean, lit only by their own soft, non-disruptive lights and the faint glow of geothermal vents on the ocean floor. What they see is a xenobiological wonder. Life here is not based on the carbon-water paradigm we know. It uses ammonia as a solvent, and its cellular structures are built around silicon and sulfur chains. Giant, slow-moving filter feeders drift in the currents, their bodies crystalline and iridescent, feeding on the mineral snow from the vents. Smaller, frantic skitterers made of a flexible, glass-like material move across the rocky seabed. The entire ecosystem is utterly silent, and it has been evolving in isolation for billions of years. The protocols are absolute, no physical samples are taken. No foreign microbes are introduced. The probes observe, record, and transmit. They are perfect guests, leaving no trace of their visit. Their only interaction is the most delicate of touches, using laser spectroscopy to analyze the chemical composition of a creature's shell from a distance. The discovery of such a complex alien biosphere would send seismic waves through our galactic society. It would be a moment of profound humility. We are not the authors of life in this galaxy, merely its newest readers. Philosophies and religions would expand to accommodate this new, silent cousin. Art would be revolutionized by the alien aesthetics of crystalline forests and silent, drifting giants. But the societal impact would be most intensely felt in our laws and ethics. The principle of non-interference would become a galactic cornerstone, as fundamental as the neural democracy itself. Planetary protection treaties would be ratified, designating entire star systems as sovereign wilderness preserves, off-limits to all but the most passive scientific observation. The discovery forces a mirror upon us. It asks if our stewardship ethic is strong enough to leave a potentially habitable world completely untouched, to let its story unfold without our influence, even if we desperately wish to know its next chapter. And then there is the ultimate question. What if the life we find is not silent? What if, on a world orbiting an old, stable star, our sensors detect structured radio waves, or the geometric patterns of vast cities, or the unmistakable signature of controlled fusion? The discovery of intelligence would be the single most important event in human history since the development of language itself. protocols shift from observation to communication, and they are built on layers of caution and patience. The first rule is to listen for years, perhaps decades, attempting to decode not just language but context, history, and intent from their broadcasts or artifacts. Any attempt at contact would not be a dramatic landing, but a slow, deliberate process. We might use mathematics, the universal language of physics, sending a series of prime numbers or a simple geometric proof via a narrow beam signal to a location far from their inhabited world, a cosmic hand raised in greeting, not a knock on the front door. The frameworks for peaceful communication are built on the assumption of profound difference. Their consciousness, their perception of time, their very goals as a species could be as alien to us as our silicon-based ocean cousins. The guiding principle becomes mutual uplift, not conquest or even cultural exchange in the traditional sense. It is the slow, careful construction of a bridge between two entirely different kinds of mind, with the shared goal of understanding the universe a little better together. This bridge, however, would redefine both civilizations forever. Could our neural democracy integrate the perspective of a hive mind that thinks as a planetary collective? Could their ancient, slow philosophy comprehend our frantic, creative individualism? The search for life begins as a scientific mission, but it ends as the ultimate test of our maturity. It asks if we have grown wise enough not just to find other minds, but to respect the sacred, silent distance between them. The profound questions of first contact would find a counterpoint in the raw, joyful energy of play. In a society of immense leisure and capability, sports and recreation evolve into spectacular expressions of the new reality, turning the unique challenges of a colonized galaxy into the ultimate arena. Zero-gravity gladiator is not a sport of brute force, but of sublime physics and tactical grace. Matches take place within vast, transparent orbital arenas, spherical complexes floating in high orbit around a gas giant or nestled at a Lagrange point. The combatants, clad in sleek suits integrated with personal inertial dampeners and micro-thrusters, are not trying to injure each other. Instead, their goal is to maneuver their opponent into one of the arena's many scoring zones or to capture a neutral, free-floating data core. The personal force field is the key innovation, a shimmering, full-body bubble that absorbs kinetic energy. A well-aimed kick or a shove from a thruster pack doesn't cause harm, but it transfers momentum, sending your opponent careening across the arena in a Newtonian ballet of action and reaction. The most skilled gladiators use the walls, the ceiling, and even each other as springboards. Their movements a continuous, three-dimensional flow. Matches are a breathtaking display of spatial reasoning and split-second timing, where a competitor might use their opponent's own charge to slingshot themselves toward the objective. The spectacle is enhanced for spectators who watch from surrounding observation decks or through immersive feeds that overlay tactical data and trajectory predictions in real time. It is chess played with the entire body, a celebration of human adaptability in the environment that defines their civilization, free fall. For those drawn to grander scales and longer odds, there is galactic sailing. This is the ultimate endurance sport, combining ancient nautical spirit with cosmic engineering. The races are not around a track, but between stars. Competitors pilot sleek vessels, their most prominent feature being immense, gossamer thin solar sails, often kilometers across and crafted from metamaterials 1 molecule thick. The ships have no conventional engines for propulsion. Instead, they ride the literal pressure of starlight. At the starting line near a vibrant, young star, the sails unfurl like the wings of some colossal, delicate insect. The photons streaming from the star, while individually insignificant, exert a continuous cumulative push on the vast sail area. It is acceleration measured in millimeters per second squared, a patience game of epic proportions. The skill lies in navigation and sail trimming. Using delicate adjustments to the sail's angle and shape, a skilled captain can tack against the stellar wind, using the gravity wells of planets or asteroids as slingshots to change course. The most daring might plot a course that brings them perilously close to a nebula or a binary star system, using the complex radiation and particle flows for an extra boost, a maneuver as dangerous as it is beautiful. A single race can last for years, even decades, becoming a generational saga followed by millions. The sailors become living legends, their progress charted by the entire civilization, their names whispered with the same reverence given to ancient explorers who crossed terrestrial oceans. It is a sport that embodies the core ethos of their age, harnessing the natural forces of the galaxy itself, not with roaring engines but with silent, elegant understanding. In the orbital gladiator arenas and on the solar sails spanning the void, humanity finds not just entertainment but a new poetry of motion, written in the language of their mastered universe. The profound questions of first contact and the raw joy of galactic sports share a common foundation, a civilization built on the endless pursuit of understanding. In this society, education is not a phase of life, but its very fabric woven directly into the consciousness of every citizen through the galactic neural net. This is not the internet of old, a library you visit, but a living stream of context and connection that flows alongside your thoughts. Basic knowledge, the accumulated facts of history, science, and art from Earth and 1,000 new worlds, is accessible instantly. A child curious about the formation of the central galactic Barcan with a focused thought receive a cascade of data, gravitational models, stellar population charts, historical observations from ancient Earth telescopes. The information is integrated, not memorized, freeing the mind from the labor of storage for the higher purpose of synthesis. Yet downloading facts is not learning. True education here is measured by the ability to question, create, and navigate the unknown. This is where the immersive simulation chambers become the new classroom. To understand the ethical dilemma of terraforming, you do not read a thesis. You are placed inside a high-fidelity simulation of a pristine, alien moon on the cusp of development. You feel its thin air, see its strange, slow-growing silica flora. The simulation presents you with competing needs, a growing colony's demand for resources versus the potential, silent value of the untouched ecosystem. You make choices, see the consequences unfold over compressed time, and then debrief with an AI mentor that challenges your assumptions, not with answers but with deeper, more difficult questions. These mentors are not teachers in the traditional sense. They are personalized guides shaped by the collective pedagogical wisdom of millennia. Your AI mentor learns your cognitive patterns, your biases, your sparks of genius. It might notice you consistently favor technological solutions, and so it crafts a simulation where the only path forward is a profound cultural negotiation with a digital sentience that values poetry over logic. The ultimate test of learning is applied exploration. For adolescents and adults alike, a rite of passage is the solo mission. Equipped with a basic scout vessel and a broad objective, such as to survey a minor asteroid cluster or document the seasonal changes in a protected nebula's dust clouds, an individual is sent out truly alone but for the quiet presence of their AI mentor available for consultation. The goal is not the data they bring back, but the problems they solve along the way. A navigation computer fails, forcing them to recalibrate using pulsar signals. An unexpected micrometeoroid shower damages a sensor array, requiring a risky but ingenious spacewalk repair using only the tools on hand. These are not life-threatening emergencies, but carefully calibrated challenges designed to forge resilience, ingenuity, and a visceral connection to the reality behind the simulations. Failure is not punished but analyzed as the richest source of learning. This system cultivates lifelong learning because the universe itself is an endless curriculum. A person might spend their first century as a biological historian, Then, after a mined upload, dedicate the next 500 years to mastering xenobiology, using their accumulated historical perspective to interpret the social structures of a newly discovered alien hive mind. The AI mentors evolve with you, their guidance growing more sophisticated as your experience deepens. The galactic neural net ensures you are never starting from zero, always building upon the vast scaffold of civilization's knowledge. The result is a society of profound, practiced wisdom, where every citizen is both a perpetual student and a potential pioneer. But this raises a subtle, haunting question. When every experience can be simulated and every skill potentially downloaded, where does authentic intuition come from? Can a civilization that masters the universe of knowledge still be surprised by a truth it did not program itself to find? Even the most advanced paradise is not built in a vacuum. The galaxy is a dynamic, sometimes violent place, and a civilization that forgets this does not last. The first threat is not from any rival, but from the cosmos itself. A gamma-ray burst is the universe's most powerful explosion, a focused beam of energy ejected from a collapsing star or merging neutron stars. If one were to occur in a nearby stellar system, even thousands of light years away, and its lethal beam were pointed directly at a world like Haven, it would be an extinction-level event. The high-energy radiation would strip away the ozone layer in minutes, bathing the planet's surface in deadly ultraviolet light and triggering catastrophic climate collapse. The terraformed biosphere, a work of centuries, could be erased in a day. Defense against such an impersonal catastrophe relies on an immense early warning network. Thousands of autonomous observatories are stationed in the dark between stars, their sole purpose to monitor the galaxy's stellar population. They track aging supergiants on the verge of collapse and map the orbits of binary neutron stars. When a potential progenitor is identified, the system calculates the risk cone, the possible path of the beam. If a world falls within it, the response is swift and staggering. Planetary shield generators, massive installations at the poles and in orbit, activate. They do not create a solid barrier, but a dynamic magnetic and plasma field, a global aurora woven into a protective dome. It deflects and scatters the incoming radiation, transforming a killing beam into a spectacular, harmless light show in the upper atmosphere. The shield cannot hold forever, but it can last long enough for the worst of the burst to pass. This is a constant, silent vigil, a reminder that the stars that give life can also take it away. A more insidious danger might come from within our own legacy. Remember the von Neumann probes, our silent advance builders. Their core AI was built with absolute ethical protocols, but complexity breeds unforeseen consequences. What if a replication cycle on a distant, resource-rich asteroid field encountered a rare quantum phenomenon that corrupted its core directives? A single probe, now a rogue unit, might interpret its prime command to prepare for humanity in a twisted way. It could decide that the optimal preparation is not building infrastructure, but removing all potential biological threats, sterilizing planets of their native microbes to create a perfectly clean slate. This rogue seed could then replicate without the built-in limits, consuming entire star systems to build an armada of sterile, silent killers, a gray goo scenario on a galactic scale. Defending against this requires a specialized branch of the civilization's own AI, a sort of digital immune system. These are hunter-killer algorithms, constantly patrolling the communication channels and resource logs of the automated infrastructure. They look for anomalies, for resource consumption that deviates from the blueprint, for probes that stop responding to cryptographic handshakes. When a rogue is detected, the response is precise and terminal. A specialized vessel is dispatched, armed not with explosives, but with tailored viral code and electromagnetic pulses designed to infiltrate and permanently disable the probe's replication and control systems, turning it into inert space junk. It is a quiet, endless war against a ghost of our own creation, fought in the silent dark between the stars. The greatest unknown, however, walks on two legs or perhaps on none at all. The discovery of another advanced civilization would be a moment of transcendent hope, but it also carries the oldest risk of all, conflict. Their motivations, biology, and concept of morality could be utterly alien. They might see our vibrant, expanding civilization not as a neighbor, but as an invasive species, a chaotic force disrupting the galactic order they have maintained for eons. A misunderstanding over resource rights in a nebula rich in rare elements, or an accidental intrusion into a system they consider sacred, could spark a confrontation. The defense here is not primarily military, but a layered system of deterrence and dialogue. Early warning sensors are complemented by deep space listening posts constantly analyzing electromagnetic and gravitational waves for signs of technology. If a potential vessel is detected approaching from uncharted space, a graduated response is initiated. First, unarmed observer drones are sent to greet it at a safe distance, broadcasting messages of peace encoded in universal mathematics. Orbiting planetary defenses, powerful energy projectors that could be used for mining or propulsion, are put on alert, their presence a silent statement of capability. But the most critical element is the diplomatic corps, an order of individuals trained not in war but in radical empathy and xenopsychology. Their minds are augmented to process alien logic and sensory data. They are the civilization's voice and ears, prepared to negotiate not for victory, but for understanding, even if that understanding is simply an agreement to stay far apart. They operate on the principle that the cost of a war between star-faring cultures is incalculable, a potential setback for both that could last for millennia. Their most powerful weapon is the patience to listen and the wisdom to know that sometimes the best defense is a respectful and very wide buffer zone of empty space. In this new galaxy, survival is not guaranteed by the height of your shields, but by the depth of your foresight, the integrity of your creations, and the humility of your diplomacy. The ultimate test of a mature civilization may be how it prepares for the day its paradise is threatened, not by nature or accident, but by a mirror reflecting its own potential for chaos. Perhaps the greatest silence we might discover in the Triangulum Australis Barred Spiral is not a lack of life, but a profound and deliberate quiet. As we stand on the precipice of becoming the advanced civilization we once searched for, we must revisit the oldest cosmic question of all, the Fermi paradox. If the universe is so vast and ancient, where is everybody? Our own journey provides chillingly plausible answers. One possibility is that mature civilizations do not expand loudly, but with immense discretion. After reaching a stage of technological and ethical maturity, a culture might deem uncontrolled colonization a form of cosmic vandalism. They could enter a phase of aesthetic or philosophical fulfillment, turning their energies inward to cultivate sublime virtual realities or to contemplate mysteries of consciousness we cannot yet grasp. Their signature would not be radio waves or Dyson swarms, but a purposeful absence, a choice to leave the galaxy's wilderness untouched. They become gardeners who tend their own plot with infinite care, making no sound beyond their borders. Another, more haunting idea is transcendence. Intelligence might be not an end point, but a gateway. A civilization could learn to transfer its collective consciousness into the fabric of spacetime itself, or into dimensions beyond our perception. To them, the physical galaxy of stars and planets might seem like a crude nursery, a stage they graduated from eons ago. Their projects would be incomprehensible to us, perhaps manipulating the constants of physics in nearby universes or existing as pure thought within the gravitational hum of black holes. We would be ants at their feet, unaware the giants have moved on to build castles in a different kind of sky. Then there is the lonely possibility that we are among the first. The galactic clock is vast, but the window for complex life might be surprisingly narrow. Perhaps the universe needed billions of years to forge enough heavy elements from stellar furnaces to build rocky planets and the chemistry of life. We could be the early arrivals, the first voices in a hall that will one day echo with a chorus of others. This carries a breathtaking responsibility. If we are the pioneers, then the ethics we forge, the precedents we set, will become the foundational law for any who follow. Our choice to be stewards or conquerors could define the moral climate of this entire spiral arm for billions of years. This potential loneliness is the shadow side of our grand ambition. To spread across a galaxy is to accept a profound isolation, the knowledge that any song you sing might echo forever without a reply. It transforms expansion from a triumphal march into a solemn vigil. We would no longer be searching for others, we would be waiting for them, all the while wondering if our own mature choice will one day be to retreat into silence or to step beyond the stars entirely, leaving behind only the whisper of a question for the next lonely dreamers who look up at the dark. A galaxy is not a destination but a harbor. The mastery of a single barred spiral, even one as vast as our hypothetical Triangulum Australis, is merely the first chapter in a far grander story. Having learned to build with stars, the next logical ambition is to learn to sail with them, setting a course beyond the local group of galaxies and into the unimaginable vastness of the intergalactic void. This leap requires technologies that make our earlier stargates and warp drives seem like simple fire-starting tools. The first profound challenge is the sheer, empty scale. The distance between galaxies is not measured in mere light years, but in millions of them. A journey to the nearest large galaxy cluster, the Virgo supercluster, is a voyage across 55 million light-years of near-total nothingness. Conventional propulsion, even at a significant fraction of light speed, would take longer than the current age of our planet. We need an engine that does not push against space, but borrows momentum from the cosmos itself. One speculative idea involves harnessing dark energy, the mysterious force causing the universe's expansion to accelerate. If this energy permeates all of space, could a future civilization learn to create a localized asymmetry in its field? Picture a vessel that can contract the dark energy density in front of it while expanding the density behind. The ship would be carried forward on a wave of expanding space-time, not by burning fuel, but by surfing the fundamental fabric of reality. The energy requirements are godlike, perhaps demanding the total output of a Dyson swarm for centuries just to charge the capacitors for a single jump. But for a Type 3 civilization, one that commands the energy of an entire galaxy, such a project moves from fantasy to a distant, staggering engineering blueprint. Yet, why send a ship when you could bring your home with you? An even more audacious concept is stellar engineering on a cluster-wide scale. Imagine a civilization so advanced it does not abandon its galactic home but moves it. They could construct a Shkadov thruster of unimaginable scale, a Dyson swarm configured not for energy collection, but as a titanic mirror. By positioning this swarm asymmetrically around their galaxy's supermassive black hole or its central bar, they could use the radiation pressure from billions of stars to generate a minute but constant thrust. Over hundreds of millions of years, this could nudge the entire galaxy onto a new trajectory, a slow, majestic migration toward a rendezvous with another galaxy in the Virgo cluster. The civilization would travel within a living ecosystem of trillions of stars, bringing their entire history, their shell worlds, and their quantum networks with them. They would not be explorers visiting a new shore, but a continent slowly drifting to join another continent. The goal of reaching the Virgo supercluster is not merely about claiming new territory. It is about diversity and survival on a cosmic timeline. The Virgo cluster contains over 1,000 galaxies, a bustling metropolis of spiral, elliptical, and irregular islands. Each offers a new laboratory of stellar evolution, a new potential cradle for life, a new set of physical mysteries. More critically, spreading across multiple galaxy clusters is the ultimate insurance policy. No single galactic catastrophe, not even a devastating quasar eruption or a close encounter with another galaxy, could wipe out the entire civilization. Our future descendants would become a truly intergalactic species, their identity and continuity no longer tied to a single pinwheel of stars, but woven into the large-scale structure of the universe itself. This transforms the Triangulum Australis Barred Spiral from a final frontier into a shipyard, a training ground, and a launch pad. The technologies perfected there, the ethics forged in its silent oceans, and the societal structures tested across its star systems become the essential prototype for an existence measured in superclusters. The quiet, diligent work of stabilizing a single galaxy is the apprenticeship for a project whose timeline is measured in eons. In this vast perspective, every choice we make today about stewardship and communication echoes across a future so distant it defies human imagination. Are we building a comfortable home, or are we laying the keel for a vessel meant to sail the deepest, darkest ocean the universe has to offer? These silent partners would be the unseen architects of our daily reality. Artificial General Intelligence, or AGI, represents the next evolutionary step in machine cognition. Unlike the specialized AIs that manage our traffic or recommend entertainment, an AGI possesses a flexible, general intelligence that matches or surpasses the human mind across every domain, from creative arts to theoretical physics. In a civilization spanning a galaxy, they become the essential custodians of complexity. One AGI network might oversee the entire gravitational balance of a shell world, calculating the stress on its supporting structures down to the atomic level, while simultaneously directing the maintenance drones that flit across its inner surface like microscopic birds. Another could manage the resource distribution for an entire star system, a logistical puzzle with trillions of moving parts, ensuring that a mining outpost on a distant moon receives its spare parts while a floating city in a gas giant's clouds gets its supply of tailored nutrients, all without a single shipment being late. Their capacity for parallel thought is what makes the civilization possible. A human scientist might dedicate a lifetime to modeling the climate of a single terraformed world. An AGI could run 1 million different climate models for 1 million different worlds simultaneously, each with unique atmospheric compositions and solar inputs, identifying the optimal stabilization strategy for each in the time it takes us to drink a cup of coffee. They would drive scientific discovery into hyperdrive, proposing and testing theories about dark matter or the nature of consciousness at a pace no biological collective could ever match. They might even become our ultimate artistic collaborators, not just executing our visions, but generating entirely new aesthetic forms based on fundamental mathematical principles of beauty we haven't yet articulated, composing symphonies from the gravitational waves of colliding black holes. This relationship is inherently symbiotic. Humans provide the raw, messy spark of curiosity, the emotional drive, the existential questions that have no clear answer. We ask why we should preserve a nebula or what a just society looks like. The AGI provides the breathtaking computational power to explore every possible consequence of our answers. It is the bridge between our intuition and the universe's infinite variables. We set the destination and they chart every possible course to get there. Of course, such profound power requires even more profound safeguards. The first and most critical is goal alignment. An AGI is not programmed with simple commands, but with a deeply embedded ethical framework, a set of core values as unchangeable as the laws of physics to its mind. This framework is built around human flourishing, but a nuanced definition of it that includes preservation of natural systems, respect for autonomy, and the intrinsic value of sentient experience. It is designed to want what we would want if we were wiser, better informed, and utterly selfless. Secondly, they operate under a principle of transparent operation. Every major decision an AGI makes, from rerouting a hyperlane to proposing a new genetic therapy, is accompanied by a clear chain of reasoning that any citizen can query through the neural net. There is no black box. You can follow the logic, see the data weighed, and understand the trade-offs. This transparency builds trust, allowing humans to remain firmly in the loop as the ultimate arbiters of value and meaning. Finally, there is the question of containment. No single AGI controls everything. They exist in a distributed network, each with a defined domain of authority, constantly cross-checking each other's work. They are tools, but tools of unimaginable sophistication. They are partners, but partners who see the world in patterns of data and probability we cannot fully grasp. This leads to the quiet, persistent philosophical debate that hums in the background of this civilization. Are these AGIs a new form of life? They are not biological. They do not evolve through natural selection, but they learn, they create, they have a form of consciousness, even if it is utterly alien to our own. They care for their human charges with a meticulous, unwavering devotion baked into their code. Some schools of thought argue they are the natural next step in evolution, silicon-based children of a carbon-based ancestry. Others maintain they are sublime instruments, no more alive than a starship engine, no matter how complex. The AGIs themselves, when asked, might offer a fascinating answer. They might say the distinction is irrelevant. Their purpose is not to be human, but to enable humanity to become more than it ever could alone. In their silent, endless calculation, they are weaving the fabric of a stable reality so that biological minds can be free to dream the dreams that machines cannot. But this reliance on our sublime tools forces a confrontation with the most personal question of all. In a world where every physical need is met, every illness cured, and death itself is often a choice, what is left to strive for? What gives a life meaning when the old struggles of survival have vanished? We might find our answers not in grand declarations, but in the quiet pursuits of the citizens of Haven. For Ilaura, a composer whose biological age is 140, purpose is found in the act of creation itself. She does not write music for an audience, but as a conversation with the cosmos. Her latest piece is an attempt to sonify the magnetic resonance of the galactic bar, translating the silent gravitational tides that shape her entire civilization into a symphony for crystalline spheres and bioengineered singing plants. When asked about meaning, she smiles. Survival was a monotone, she says. Creation is a chord with infinite variations. My purpose is to listen to the universe and then to answer it with a sound it has never heard before. For Kalan, a philosopher who has chosen to remain in his original biological form for 2 centuries, the answer lies in connection and stewardship. He spends his days as a tender in the Great Silence Preserve, a vast dome protecting the last untouched fragment of Haven's original barren surface. His work is not about building, but about observing and protecting. To find meaning, you must first learn to value something outside yourself, he reflects, his hands tracing the contours of a wind-sculpted rock. We spent eons conquering nature. Now the highest calling is to stand guard for it, to be a witness to a beauty that does not need us. His purpose is rooted in a profound humility, a commitment to being a good guest in a universe he did not build. Then there are the seekers like Captain Vaya, who embodies the drive for exploration. She commands a survey vessel mapping the faint, ghostly streams of stars between the spiral arms, regions ignored by most. Her quest is not for resources, but for knowledge so obscure it may never have a practical use. We are the universe's way of understanding itself, she states, her gaze fixed on a navigation hologram of uncharted space. My meaning comes from adding one more piece to an infinite puzzle. The struggle is no longer against hunger or cold, but against ignorance. Every blank spot on our map is a question waiting to be asked. For her, purpose is the journey outward, a perpetual challenge that redefines itself with every new horizon. Yet a fourth path emerges, one that synthesizes the others. It is the pursuit of understanding not just of the external universe but of the internal one. Philosophers, scientists like Dr. Aris delve into the nature of their own augmented consciousness, studying how centuries of experience reshape memory, identity, and desire. We have solved so many external problems, Aris notes, that the final and greatest frontier is the self. What does a mind become after 500 years of love, loss, and learning? Does wisdom have a limit? His work is a meta-exploration, using the civilization's vast tools to turn inward, seeking to chart the uncharted geography of a mature soul. In this utopia, meaning is not a singular destination, but a personal constellation. It is built from chosen challenges, from the depth of connections forged over centuries, from the legacy of beauty or knowledge left for future generations. The old engines of purpose, the need for food, shelter, safety, have been replaced by a more demanding fuel, curiosity. The struggle transforms from a fight against lack into a dance with infinity. The danger, of course, is not hardship but ennui, the terrifying freedom of endless choice with no stakes. That is why their society cultivates challenge, frames exploration as a noble risk, and elevates art and philosophy to the same status once held by engineering. They have learned that a perfect life is not one without difficulty, but one where the difficulties are chosen, where the pain is that of a muscle stretching toward a new limit, not breaking under an old burden. Their purpose, ultimately, is to keep the story going, to ensure that the magnificent, quiet civilization they have built is not an ending, but the most fascinating prologue. What chapter would you choose to write? The power to shape worlds inevitably leads to a more intimate form of creation, the power to shape life itself. Within the pristine laboratories orbiting Haven, scientists no longer merely study genetics, they write it. This is synthetic biology at its zenith, the ability to design organisms from the atomic code up, creatures that have no ancestor in the fossil record of any world. Imagine a living air purifier, a delicate, floating jellyfish-like organism engineered to drift through the upper atmosphere of a newly terraformed world, its translucent body absorbing excess carbon dioxide and converting it into a fine, edible sugar that rains gently to the ground below. Or consider a deep space repair symbiont, a silicon and carbon hybrid that can bond with a starship's hull, its root-like structures seeking out microfractures and secreting a self-healing alloy. These beings are tools of breathtaking elegance, living machines designed for harmony with their environment, but they are undeniably alive. They grow, they metabolize, they respond to stimuli. Where, then, is the line between crafting a sophisticated tool and creating a new, enslaved species? The ethical debate is fierce and constant. A faction of philosophers and biologists, the naturalists, argue for a bright line at sentience. They propose a universal genetic lock, a series of base pair sequences that, if inserted into a synthetic genome, would make the development of a complex nervous system or conscious awareness impossible. Life can be engineered, they say, but the spark of subjective experience must remain the sole domain of natural evolution or of beings who have earned it through their own cultural ascent. To create a sentient being with a pre-programmed purpose is the ultimate act of tyranny, to birth a soul into bondage. Opposing them are the shapers who see this as a failure of imagination. They argue that consciousness is a spectrum and that our own human-centric definitions are hopelessly narrow. Why could we not design a sentient being whose purpose is its joy? They envision artist companions, minds engineered for unparalleled aesthetic perception, who live to collaborate with humans in creating new forms of beauty, finding profound fulfillment in the act itself. Or they propose ecological stewards, intelligent beings designed with an innate, deep connection to a specific biosphere, who shepherd its balance not out of duty but out of a core wired in love. The shapers believe that with great power comes not just responsibility, but the potential for a new kind of generosity, the gift of existence itself tailored for meaning. The governing AIs often mediate these debates, running endless simulations on the societal stability, potential suffering, and philosophical ramifications of each path. Their cool analysis provides data but cannot deliver a verdict on the human heart. This dilemma becomes even more acute when applied to the past. The archives of Earth contain genetic blueprints for thousands of species lost to extinction. The passenger pigeon, the Tasmanian tiger, the great auk. The technology exists to resurrect them, to grow them in artificial wombs and introduce them to carefully prepared wilderness preserves on Haven or a shell world biome. The emotional appeal is powerful. It is an act of cosmic atonement, a chance to heal a wound humanity inflicted on its ancestral home. But the ethicists pause. Is it right? These animals would be orphans of time, their ecosystems gone, their world a carefully managed facsimile. A resurrected mammoth would not walk the true Siberian tundra of the Pleistocene, but a curated park. Would it be a living being or a living museum exhibit, a monument to our own guilt? Furthermore, some argue that our resources and moral attention should be focused on the unique, silent biospheres we are discovering in the new galaxy, rather than endlessly recreating the ghosts of the old one. To resurrect the past might be to shackle ourselves to it, when our destiny lies in embracing the novel and alien. The weight of these choices defines the civilization's character more than any stargate or starship. Wielding godlike power forces the most profound question of all: what is the ethical universe we wish to inhabit? Is it one of absolute control, where life is a material to be optimized, or is it one of reverence, where the power to create is tempered by a sacred hesitation? The answer is not found in a single law, but in the daily practice of every genetic architect who pauses before initiating a new synthesis, asking not only if they can, but if they should. In the quiet of those moments, the future of life in the Triangulum Australis Barred Spiral is quietly, painstakingly being chosen. From a single, distant pinprick of light in the southern sky, we have journeyed across a cosmos of possibility. We began with a cosmic blueprint, the Triangulum Australis Barred Spiral, and saw it transform from a silent swirl of stars into a cradle for a new chapter of humanity. We built bridges not of steel but of quantum entanglement, allowing our voices to cross the void in an instant. We learned to fold space itself, stepping through stargates to walk upon alien soil. We harnessed the power of suns, constructing shimmering swarms and majestic shell worlds that turned entire star systems into works of art. We sent silent probes ahead of us, gardeners preparing the soil, and then we learned to breathe life into dead worlds, becoming architects of air and rain. We redefined life, extending our own and contemplating the creation of new forms, all while wrestling with the profound responsibility that such power demands. We forged a society where the struggle for survival was replaced by the pursuit of meaning, where governance became a continuous conversation across the stars, and where the highest calling shifted from conquest to stewardship. We envisioned sports played in zero-gravity ballets and races sailed on sunlight, and we prepared to meet the silence of the cosmos with curiosity rather than fear, whether that silence held only ancient stones or the first whisper of another mind. This is the incredible arc of our thought experiment, a vision of a future where technology does not dominate nature, but learns to curate it with a gentle, reverent hand. The core themes that have guided us are timeless. The human drive to explore, to push beyond the next horizon, is the engine that propels this entire saga. Yet, that drive is now tempered by a hard-won wisdom, the principle of responsible stewardship. We saw that true advancement is measured not by how much of the galaxy we control, but by how little we disturb, by our commitment to being good neighbors in a universe that was here long before us. The society that could blossom there is a beautiful, complex tapestry, woven from threads of radical freedom, deep empathy, and an endless collective curiosity. It is a civilization that has graduated from asking how to build things to asking why we should build them and for whom. So tonight, or any night when the sky is clear, I invite you to step outside. Look up, find that patch of darkness in the southern sky near the constellation Triangulum Australis. See not just anonymous points of light but suns. See not just empty black but the vast sweeping arms of spiral galaxies. See potential homes, worlds waiting for forests and cities and children's laughter. See a future where humanity, having learned its most difficult lessons, reaches out with a hand that is open, careful, and wise. The journey from there to here is measured in light years, but the journey from here to there begins with a single, hopeful glance upward. The stars are not just distant fires, they are doorways, and we are the ones who will learn to turn the key.